Hello. So you'll be presenting on membrane filtration in Kraft process for enhanced vanillin recovery from wood chips. My name is Oscar Mponsa and my colleague is John Kennedy Minan. So I'll start by saying with the growing challenges of climate change and resource depletion, biomass and its derivative offer a sustainable alternative to these traditional based products, and they align with the principles of circular economy. Hence, there's a need for us to integrate highly effective systems like the membrane separation units into biorefineries to increase the production of these bio-based materials. And the Kraft process is the commonest process used in the pulp and paper industry, accounting for 2/3 of the global virgin pulp and 90% of chemical pulp. So specifically for our starting material for the Kraft process, we selected birchwood biomass, and this is a typical composition of the birchwood biomass. You realize that the lignin composition is relatively higher, which is 26.4. And since we are producing vanillin and our target compound will be the vanillin from lignin, it's only imperative that we use the birchwood biomass. So this is an overview of the Kraft process. So in this overview, we have two filtration units, one after the sulfur-based pulping process. So these filtration units will be used to separate the brown stock to obtain a crude fiber which can further be processed. And then the second filtration unit will be used to separate the hemicellulosic solution from the crude lignin, which can further be processed to get our Kraft lignin for the vanillin production. So the Kraft pulping typically involves cooking the biomass in white liquor at elevated temperatures and pressure. And the media is usually sodium hydroxide and sodium sulfide. So the process occurs in 3 stages, after which we are going to obtain cellulose, lignin, and hemicellulose as our fractions.
Okay, the main separation membrane technologies used are ultrafiltration, nanofiltration, and microfiltration because of their low operational cost and high separation efficiency. For ultrafiltration, the molecular weight cutoff ranges from 1 to 500 kilodaltons, while that of nanofiltration is below 1 kilodalton, making them able to selectively retain hemicellulose and lignin while allowing smaller ions and water to pass through. Now, these membrane technologies are pressure driven. For microfiltration, the operating pressure is below 2 bars, whereas for ultrafiltration, the operating pressure ranges from 1 to 10 bars. And these two technologies, separation mechanism is a sieve mechanism where the separation is based on the size of the particles. And the membrane structures are either symmetric or asymmetric. Now, in the case of nanofiltration, the operating pressure ranges from 5 to 35 bars, while the separation principle is based on solution diffusion, where particles move from area of higher concentration to that of lower concentration, while its membrane structure is a composite structure. And for recommended membrane materials, you can either use polymers or ceramic materials because of their good chemical resistance and temperature resistance. Now, the recommended membrane technology for each stage: in the stage of crude cellulose separation, we can use microfiltration, and the main fouls here are bags and nuts. And pre-treatment technology that can be recommended here is screening or hydrocyclones. While in the separation of lignin or hemicellulose from black liquor, we can use either ultrafiltration or nanofiltration. And the main fouls here is lignin or hemicellulose. And pre-treatment method that can be used is either we can use alcohol to precipitate lignin, hemicellulose from the black liquor, or we can use acids to precipitate the lignin. And then microfiltration as well can be used as a pre-treatment technology. Now, for post-processing, crude cellulose fibers can be purified using solvent washing or bleaching to remove lignin, while hemicellulose can be precipitated with alcohols or ammonium sulfide. While the lignin, which is our main product or our target product, can be evaporated, dried, and later on depolymerized to produce valuable products like vanillin. And this vanillin can be further purified using chromatography. Now, applications of vanillin: it can be used as drug carriers, hydrogels, drug intermediates, and so many other applications. Thank you all for listening. And here are our references.